Okay, let's see if you remember how to graph three basic things. Can you graph this for me on that graph paper? Because how are you going to graph the really complicated ones if you don't know how to graph the basic ones? I totally would get blanking and going like, I don't remember how this looks. And you'd have to make an XY chart, find a bunch of points. The reason that XY chart is so powerful is because you could have completely forgotten how to graph 1 over x. And all you'd have to do is find like 5 points. And here's where they'd be. Be a point here, there'd be a point here, there'd be a point here, there'd be a point here, here, and here. And then you'd be like, oh, that's right. This is the one that has asymptotes. I connect mine with yellow lines. There. So again, the XY chart could save your day. You'd put in things like 1 and you'd get 1. You put in 2 and then you'd get y equals 1/2. So you can graph these by just an XY chart. It would totally work. But it'd be way faster if you knew what they look like. This one, I know the slope and the y-intercept. Take a second and graph this on the same graph, just to save you time. There's no reason we have to switch graphs. Just choose a different color. You know, we made that first one in black. Make this next graph in like green or something. So, don't make an XY chart for this one. Use the fact that the y-intercept is 4. But I guess if you work just completely stumped, XY chart would work. Stick in x is 0 and you get 4, aka the y-intercept. All right, since I said to just do it on the same graph, it'd be kind of like this. A fairly steep line. Okay, so fairly steep line that goes through 4. Again, if you want it on a separate graph, I could show you that. Steeper than that. Rises 3, runs 1 to get to the next point, you know. Okay, last but not least, graph this. You can make a new one for this, or you can put it on the same one. I don't care. I just want you to remind yourself of the basic graphs. Because all it is the basic graphs plus holes. So for this, we just got a parabola that shifted down 2. Kind of looks like that. So, didn't we already get tested on that stuff? Yeah. So why would we have a question that's exactly the same? We wouldn't. But what if we had this same question, put a parenthesis around this, and then put an x plus 3 and an x plus 3 here and x plus 3 there. Don't write that, just listen and think. Do you get I just added a hole to the graph? Because see, the hole would happen at -3. So then I go over -3, and then I go up to where the graph would be, like there about, and then I'd put an empty spot. That's it. That's all you'd have to do for today's assignment and for on the test is you typically just have to graph stuff you've already graphed before, except know how to factor it so you can get that hole canceled out. And then remember that that would mean that -3, comma something would be a hole. And it's so much easier on graphs because you can just go to where -3 is, go up to where the graph was, put an empty spot. You don't have to work so hard at figuring out what the other part of the hole is. Now, we can do it. It's not that hard. I can take that -3. I can put it right here. And then I'd have -3 squared is 9. 9 minus 2 is 7. So it would have to be at -3 comma 7. That's where that spot would be. But I'm not so worried about that when I'm on a piece of graph paper. All right. So now let's take a step back. And I want to review with you and then do a little, just kind of like a informal quiz of how to do some basic stuff from the last couple days. I said I would keep practicing this. I will. Can you get a common denominator for that? We still are getting, typically 6 kids are getting it wrong. Gotta keep practicing till, for all of you, it's fluid and easy to get common denominators for these rational functions. All right, I'm going to be hoping for only like 3 kids getting it wrong. Down to only 3 would be great. You're multiplying by the other denominator. And the denominator is now x times x plus 3. We don't multiply that out, otherwise we'd have to factor it again. Then this part is the tricky part. This part's easy because you're just timesing by 1, so it's x plus 3. This part, there is implied parentheses right here. Did you know that? That there was no parentheses written there, but you have to know that when you multiply this by x, you're not just multiplying the 4 by x. It's the whole top is being multiplied by x. And that negative is going to have to be distributed to both parts. So it's going to be negative x squared and negative 4x. And a ton of kids are going to be like, well, I just forgot that one negative. That's the whole point. That negative right there. Be careful. Okay. Why? Because this negative will distribute in. Okay. Now I'm going to simplify it down. And I have negative x squared minus 3x plus 3. And did you factor out the negative yet? If you didn't, you should do it now, because it'll tell you whether or not this thing will factor. Strong encouragement to factor out that negative, because on the test, it's very likely, I'm not promising, but it's very likely that we'd make this setup so that there would be a hole. I mean, that's a big part of this unit, so that probably would mean there's going to be something that would factor in there. And you wouldn't know until you factored the negative out and got plus 3x plus 3. And then you'll know, oh crap, it doesn't actually factor anymore. So in that case, at least you checked. All right, I would have taken this or this. Who got one of those two? Raise your hand if you got one of those two right.
Shouldn't it be a negative 3
Oh.
at the end? Because when you take out the negative.
Okay, double checking, double checking. Yes, this one was right. This one, when I took the negative out, you're right. That should have been a negative 3. Who had one of these two answers? Again, I want to check and see if I met my goal of only 3 kids getting it wrong. All right, I think we met the goal. Nice. Okay, now what else do you have to know? Oh, so much stuff. But for today, it's about graphing. And so when you get hit with something that looks really scary and they say to graph it, a lot of times what happens is tons of things drop out. Do you get in this case? That drops out, that drops out. But then how do you actually graph what's left? Take a second, graph it. You'll either know how to do this or you won't. I don't need graph paper for this, just like make a quick sketch. Maybe you haven't simplified the function down and written what it is. That's one of the biggest problems. People cancel it, and then they don't like write what they have left. So the point is, after this stuff all canceled, what you have left is y equals 2. Now, you might have forgotten what that looks like, but you would at least start with where y is 2. That's the one spot that for sure y is 2. And then from there, you have to decide, should I go up and down or should I go left and right? If you go up and down, you're at other spots where y is not 2. So that doesn't make any sense. It has to be this way. Is that the final answer then? Just a straight line like that? No. It's got 2 holes. Take a second, put them in the right spot. Now, I don't need you to do a complicated, with a hole is exactly here. You can do that, totally can, but you don't have to, because in this case, it's going to confuse you a little bit. If you just look at this line, and you know there's a hole at -3, right? Go to -3. That's where -3 would be. And you know it has to be on this line, so you can just make an empty spot right there. And another empty spot at -7, which I'm going to say is right there. And then I just put empty spot right above the -3, empty spot right above the -7. And that actually might help me to know exactly where they are. They're at -3, 2. Because see, y is 2. No matter what you put in for x, y is 2. So one of the holes is at -3, 2. And the other one must be at -7, 2. Okay, so look, it's a straight line. You got to be able to graph a straight line. Be surprised, though. I get tons of kids where after they canceled out a hole, they got this, and they're stumped on how to graph it. Take a second, see if you'd be stumped. How do you graph that? For some of you, it's going to be like, that's insulting. I've been doing this since 6th grade. But you know it's going to be more complicated than that. But fundamentally, if you can't graph that part, then how on earth are you going to graph it when it's got this in it? Put that in there too and graph that now. And in a moment, I'm going to have you compare with the kid next to you. See if you understood this. The guy behind you. All right, take a second. Compare with the person behind you or next to you. Person I always compare you with. Not compare you. Pair you with. Pretty steep line. And then at -1 here, I'm going to follow it down, and right there, I got to punch a hole in my graph. There we go. Uh-oh. Uh-oh. +1. Thank you. Man, having a rough day. Changed the problems up from last hour because I thought I could teach it better. So I'm making more mistakes than usual. Sorry about that. This would not go through exactly 1. So let me think this through. Since it goes 1, 2, 3, and over 1, it would be right there. Empty spot right there above the 1. Okay. Oh. So, what do you have to do for your homework for today? It's questions like this except backwards. What are you talking about, server? What if I just gave you this graph right here? And I said, well, what's the equation for it? And so it's sort of like Jeopardy, where I'm giving you the answer. What would be the question? Well, obviously we know the answer is this. How you would have gotten that? Well, try to remember this advice. Always deal with the whole last. So what you would have done is you would have looked at this equation and go, what's the y-intercept? What's the slope? Looks like it's rising 3 and running 1. And then you could write this part. And the last thing you do is figure out, ooh, if I'm going to put in a hole, you make parentheses on the top and the bottom. And just figure out what to put in. Well, it's right above the 1. So then I'd have to put this here and here. Let's do one like that. Don't copy this. All you do is write the equation for what I put. Okay? So imagine a world where I have one of these graphs that has asymptotes in both directions. And it goes like this and this. You'd need to know how far over I shifted it, right? I shifted it over 4 and up 2. And right above the 5, I'm going to punch a hole in my graph right there. Right above the 5. Can you write the equation for that? Do the whole last. Record. Fundamentally, is this a y equals x function? Or y equals x squared? Neither of those. What is it? 1 over x. Good. But it's been moved. Which ways? Yup. To the right 4 and up 2. Then you do the whole last. Here and here, I'm going to put an x minus 5 because it's right above the 5, see? And an x minus 5. And this is a little thing, but it's very important. Pay attention to this. Right now, it looks like you only multiply by the 4. I think you know this, but you'd need this in your answer. You'd need parentheses right there. Be careful. It's one of the most common things I mark wrong, is because if you without those parentheses, you're saying you should only multiply the 4 by the x minus 5. See, then, long story short, put those parentheses in, please. It's possible that I have to check with my colleagues on whether or not we would mark that wrong. It's such a small thing, and these are hard problems, I understand, but just put the parentheses in and you know you won't lose the credit. We try to talk to each other about little things on how we grade the test so that one of the teachers isn't like Mr. Meanie Pants and somebody else is being Mr. Generous. All right, so I think you're ready, but we should do one more review of horizontal asymptotes. There's Bob, means that it's a bigger degree on the bottom, Sob, and Bot. Do you remember the shorthand, like what you do? These are all y equals things to get the horizontal asymptotes. Sometimes there isn't any. Sometimes you can't really tell me what the answer is. Don't do this one yet. I'm just asking in general. What are the rules for bobs, sobs, and bots? Do you have those memorized yet? Okay, write down. I would be able to write down. At most, I would need 3 words to describe what to do. Now, I know some of you have forgotten. They're like, well, I know this one, but I don't know the other ones. So take a second. Talk to the kid next to you. How do you do it if it's a bob, sob, or a bot? Use just a couple words. Okay, so I think the one that people will do the easiest is the bot. Because no bots. You don't have an asymptote. The answer is there isn't any. If it's bigger degree on top, there isn't any. It's just none. And I say no bot to help you remember, like, no asymptotes for a bigger degree on top. Okay, how about same on both? That's the hardest kind, but it's a 1-word answer. Ratio. And I suppose if you wanted to make it 3 words, of the LC, maybe 4 words, lead coefficient. It's a ratio of the lead coefficients. And this last one is Bob. Who remembered the word outside? Very good. Because it's whatever's outside. And some of you think the answer is 0 on the Bob. It's usually 0, but it's not always 0. So we're going to just do a quick rapid fire. What would be the horizontal for this? Is it a bob, sob, or a bot? It's a bob. What's the word we remember? Outside. What's on the outside? Does that mean there's no asymptotes? No, it's y equals 0. All right, how about now? X over x plus 2. Talk to the kid next to you. What's the horizontal asymptote for that one? Same on, this is the same on both, so you'd use a ratio of the lead coefficients. So 1 divided by 1, so y equals 1. Okay, and how about the horizontal asymptote if I make it bigger on top, like that? How about the horizontal asymptote now? No, there's none. No horizontal, no bots. If it's bigger on top, you have no horizontal asymptotes. Okay, good. Then you should be able to take this little equation I just wrote right here, and you should be able to tell me very simple things about it. The domain, the horizontal asymptote, the vertical asymptote, and the whole. If I asked you for the domain, the horizontal, the vertical, and the whole, those should be like easy peasy for you now. Almost to the part where you can have some freedom, time to get homework done. Skip some of the homework questions. I was originally going to assign them all, but I decided to do some extra review with you instead of assigning quite so many. All right, here we go. Row 2, person 2. Isaac, that's you. Domain is?
All real numbers except x cannot equal -2.
Very good. That little -2 then is either a whole or an asymptote. So, row 5, person 2. Allie Carr, that's you. Is that a hole or an asymptote there at -2? It is. So there isn't any hole. Because the only thing we have is the horizontal asymptote. And if you were thinking this would cancel this, no, this is part of an add problem. You cannot cancel one of those and make a hole there. So the only thing that would cause a problem is this, and it's a vertical asymptote at -2. There isn't any hole. The horizontal, it's bigger on top, so there's also none there. Making sense? Okay, cool. You've reviewed, you're in a good spot up to here. Now the homework. Everybody find the worksheet for today. I'll get started with you, and then we will skip a fair number actually. Trying to keep your assignments reasonably sized so it doesn't feel like torture. It's just extra practice. All right, let's go through it right away and tell you which ones that you can skip. We're going to do all of 1 through 4. They're actually really easy. Might not seem like so at first, but I'll show you. We are going to skip number 6. We're doing 7 and 8. We're skipping 9 and 10. Now, 11, 12, 13, 14, it might seem like, look at all those problems you have to graph. No, they already gave you the graph. So all I got to do is write the equation. Let's do it for the first one. You'll see how easy these can be. What's the equation for that line that goes right across at 1? It's y equals 1. But, Mr. Breen, what's the but in this problem? So I put a parenthesis like this, and what do I put in it? X plus 2 and x plus 2. There you go. There's the equation for that. You always do the whole part last. You just ask yourself, what would the equation for the rest of it be without the whole? And then at the end, you slap the hole in. All right, what's this one? Well, it's just a parabola that's been shifted down a little bit. So y equals x squared, but it's down 4, so I go minus 4. And then, boop. Include the hole, and don't forget these green parentheses. It's only going to be up there for a second, so you may want to copy it down quick. And then I'll go back to number 1. Now, a quirk of the recording software I use is that I can't go back a page, otherwise it'll screw up the order of the recording. So, Wrecker, would you read me number 1?
F of x equals 2x plus 10 over x plus 5.
Okay. And would you agree that the top can factor?
Yes.
Can you tell me what you factored it to?
2 in parentheses x plus 5.
Perfect. And then the x plus 5 on the top and the bottom cancel and make a... What does it make? A hole. It makes a hole. And you should write the resulting function. Like, this is so messy. It really is just y equals 2 after all of that. Because, see, it started with y equals, and then everything canceled. It's up to 2. So y equals 2. So you graph it, and you put y equals 2 as a line like this. You just got to put a hole in at -5. So you go to where -5 would be. So I think it's about there. And I put in a hole at -5. Okay. So, if you get stuck today and you're like, well, first of all, I hope you walk up and ask me for help. But XY charts do work. You stick in any number you want, you find a bunch of points, connect the dots. That still works. And it's one of the best ways when you get stumped. Find a bunch of points on the graph and you'll realize, oh, now I recognize what graph this is. Okay, yes.
On the at y equals 2 graph, what would the horizontal asymptote be? Because isn't the horizontal asymptote everything but 2?
Okay, so if it's just y equals 2, and you ask me what is the horizontal asymptote, there isn't any horizontal asymptote because just a single number like this you already know what the graph is for y equals 2. And there, you just look at it. Is there any horizontal asymptote on that thing?
No.
No. There you go. So if it's a single number, it kind of breaks, those little rules kind of break down a little bit. It's like there isn't, well, I could put a bottom and a top on it, but they're both, they don't have a degree on the top or the bottom. And so then how do you decide what's bigger? And it gets too weird. So there isn't any. You can also just say, this is one of those cases where you have to go, don't overcomplicate it. It's y equals 2. Done. There isn't horizontal or vertical asymptotes. All right. So you got a bunch of time to work. Come up and ask for help if you need it.